Class Test 1, Question 10. Integrate x times e to the x with respect to x. We're going to use integration by parts. So we're going to let u equal x and dv equal e to the x. If we differentiate u, we get du is equal to dx, and we integrate dv, we get v is equal to e to the x. The integral is equal to uv, so there's uv minus v du. Okay, the integral of e to the x dx is equal to e to the x, and then we need a constant of integration. So we have e to the x in this term and e to the x in this term, so we take those outside a bracket, and there's the answer to part 1. Part 2, when we have something 1 minus something squared, we tend to think of this as a sine or a cosine. So let's say that square root of 7x is equal to sine u, and then differentiating that, we're going to get root 7 dx is equal to cos u du. And remember, root 7 is a constant, we don't need to differentiate that. So putting that into the integral, we get the following. We've got cos u du from here, but remember the root 7, which is dividing. We had a 2 in the integral here, which is we've taken outside as well, and 1 minus 7x squared is replaced by 1 minus sine u squared, and that's under a square root sign. So 1 minus sine u squared is the same as cos u squared. We have a square root bracket here, so we can square root and a square, so we can cancel those. Now we have a cos u in the denominator and a cos u in the numerator, so they can cancel. Now if we integrate du, we're going to get u plus a constant of integration, and then we back substitute for u with this here. So we're going to get 2 arcsine root 7x over root 7 plus the constant of integration, and that's the answer to part 2.